Okay, so in this video, we're going to go over some of the worksheet practice, specifically the ones that we did not do in the first instructional video. As you can see on the left side of the worksheet practice, I've laid out the questions that you'll be kind of asking yourself as we go along. Is there a GCF? If so, factor it out. If not, how many terms does the expression have? And then based on the number of terms using the flow chart, what is the method that we're going to use for factoring? So this is just going to go through kind of all the different steps, the thought process, and then also simultaneously going through the answers as well. So here we go. So number 2, is there a GCF? So looking at this, I noticed that we have 6 and 36m. What stands out to me is that 6 is a factor of 36, and both of them have an m, so yes, this does indeed have a GCF. What is that GCF? Well, we know that 6 goes into both terms, so let's start by looking at it like that. So the first term, if I use 6, is 6 times m, and 36m is 6 times 6 times m. So then to find a GCF, you ask yourself, what do they have in common? These two terms happen to have 6m in common. So when I factor out 6m, what's left behind? Well, let's see. When I take out 6 and m from the first term, I'm left with just m. When I take out 6 and m from the second term, I'm left with just a minus 6. Now, sometimes you'll be done after you do your GCF factoring. Other times you're going to have to continue on. So the next question is, how many terms does it have? In this case, we're looking inside of the parentheses and asking ourselves, how many terms is that? Well, it looks like there's 2 terms inside of the parentheses. So if you look at your flow chart, which hopefully you have out while we're going through this video, when you have 2 terms, if it's not a difference of 2 squares, you are done. So I look at this and I notice it is a difference. It does have 2 terms, but m is not a perfect square, and neither is 6. So therefore, our only method here was to factor out the GCF. So we are actually done. The answer here is 6m times the group of m minus 6. And that's all that we can do for number 2. Moving on to number 4. Asking ourselves the same series of questions again. We have n squared plus 7n minus 8. So first question, is there a GCF? First of all, there's no leading coefficient, so that means that, the only number that really goes into all 3 of these is 1. So no, there is no GCF here. How many terms does it have? I see 3 terms. And whenever you have 3 terms, that means it's a trinomial. So the next question you'll ask yourself is there a leading coefficient? Do you see a number out in front? No, I don't see a number out in front, which means my method is going to be P's and Q's. So for P's and Q's, we just play the game. What 2 numbers have a sum of the middle term and a product of the last term? So in other words, what times what is negative 8, that when I add them together, I get 7. So while you're thinking about what those might be, I'm going to go ahead and set up our answer here. Our answer is going to be a product of 2 binomials. The first term in each binomial is going to be n, because n times n is how I get n squared. And then from here, we're just trying to figure out what are the values of p and q. So I noticed that 7 is 1 away from 8, which leads me to believe that 1 is probably one of my factors. So I'm going to think about it in terms of 1 and 8. Now the question is, which one's negative and which one's positive? Well, let's see. 7 is a positive number, which means if I made 8 negative, this wouldn't work, because 1 plus negative 8 is negative 7. So I'm going to make negative 1 and 8. Negative 1 times 8 is negative 8. Negative 1 plus 8 is 7. So my 2 numbers are negative 1, negative 8. Oh, excuse me, positive 8. Let's do a quick check. N times n is n squared. Negative 8 times, negative 1 times 8 is negative 8. And negative 1 plus 8 is 7. So there's your final answer for number 4. Moving on here, these do become a little bit more challenging as we go, so we're just going to do the best that we can. Number 6, start off with, is there a GCF? So the first thing that stands out to me is that there is a leading coefficient of 2. So when there's a leading coefficient of 2, check that to see if it's a factor of the other 2 terms. Does 2 go into 8? Yes, it does. Does 2 go into 64? Yes, it does. That means yes. there is a GCF here, and that GCF is going to be 2. So the first step is we're going to factor out 2, and then write what we have left over. So when I factor out 2 from 2k squared, that leaves me with k squared. When I factor out 2 from a positive 8, that leaves me with positive 4k. And when I factor out 2 from a negative 64, that leaves me with negative 32. All right, now we move on through the questions. The next question is, how many terms does it have? And again, we're looking at what's inside of the parentheses here. So when I look inside of the parentheses, I see 3 terms, 1, 2, 3. When it's 3 terms, I look in the flowchart and I ask myself, does it have a leading coefficient? So this 2 is no longer a leading coefficient. That's a factor in the product. I'm looking at the k squared plus 4k minus 32. Is there a number out in front? No. That means I'm going to be using p's and q's to factor the inside trinomial. All right, so we play the p's and q's game. What 2 numbers have a sum of 4 and a product of negative 32? So what times what is negative 32? Then when I add them together, I get 4. Let's see, coming to mind, factors of 32, I'm thinking of 8 and 4. So if I used 8 and 4, that's how I get 32. Which one is negative to make a positive 4? The negative 4 must be negative. So 8 and negative 4 is how I get 4. So over here, in my final answer, the 2 is still a part of my final answer. Now I'm going to set up my 2 binomials. K times k is how you get k squared, so the first term in both is k. And then I bring in my p's and q's, positive 8 and negative 4. Let's do a quick check. K times k is k squared. 8 times negative 4 is negative 32. 8 plus negative 4 is 4. And then if I multiply all of these by 2, 2 times k squared is 2k squared. 2 times 4k is 8k, and 2 times negative 32 is negative 64. So I have fully factored number 6. Okay, our last one, number 8. This one should stand out because it's the only one that has 4 terms in it. So first I ask myself, is there a GCF? There's definitely a GCF of the first 2 terms. There's definitely a GCF of the last 2 terms, but I don't see a GCF of all 4. 2 goes into these 3, but it doesn't go into this one. So no, there is no GCF here. How many terms is it? There are 4 terms, which means I automatically know that I'm going to do factor by grouping because there is no other way to factor a 4-termed polynomial that we know of. So here we go. Step 1 in factor by grouping is to put in your groups. Since it's already addition, I can just kind of put in my groups like that. Step 2, factor out the GCF. So what's the greatest common factor of 12 and 3? I know 3 goes into both, so let's write them both as products using 3. I'm going to use the same color here. So 12 is 3 times 4 times n times n times n, because there's n to the 3rd power. And then this is just minus 3 times n. Over here, 16 and 4, 4 goes into both. 16 is 4 times n, and 4 is just 4 times 1. All right, let's see. What do they have in common? So I see a 3 and an n times n in the first ones, which leads me to believe that the greatest common factor of the first 2 binomials is 3n squared. Let's see what we have left over after that. Let's see, if I take out the 3 and the n squared from the first term, I'm left with 4n. And if I take out the 3 and the n squared from the second term, you might think I'm left with 0, but remember, you're essentially dividing both of these terms by 3n squared. So when I divide 3n squared by 3n squared, I'm actually left with 1. All right, in the second one, what do they have in common? I see a 4, and that's it. I don't see an n in both terms. So I'm factoring out a positive 4. What do I have left over? In the first term, I have 4n, and in the second term, I have minus 1. Let's see, is there a common binomial factor? Yes, there is. My common binomial factor is 4n minus 1. And then what's left over? Well, the second binomial is the combination of the 2 GCFs, 3n squared plus 4. All right, and that's how you do numbers 2, 4, 6, and 8. Let's go ahead now and look at the next ones, numbers 10 and 12. And the reason why I have 10 and 12 on the same piece of paper is because there's 2 different ways to do 10 and there are 2 different ways to do 12. Actually, no, I'm sorry, that's incorrect. I'm gonna end up, there's only one way to do number 10. So we're just gonna pretend like that's not there. There is two ways to do number 12 though, but really there's only one way to do number 10. So just like class, I'm gonna go ahead and white that out like it didn't exist. All right, let's take a look at, oh wait, no, that's wrong. There is two ways. Oh, sugar. Oh man, this is really like class, isn't it? Miss Angel making mistakes all over the place. There are two ways to do this one. I was confusing it with a different one. Okay, so my bad. It is a little bit weird, but whatever, we'll go with it. Okay, question 1 in number 10, is there a GCF? So there is a leading coefficient 2. Does 2 go into 11 and 15? No, so there is no GCF here. How many terms does it have? It has 3 terms, which means it's a trinomial. So you ask yourself, if it's a trinomial, does it have a leading coefficient? Yes. Is it a perfect square trinomial, meaning are the first and the last term perfect squares? Well, 2 is not a perfect square, neither is 15, so no. Which means our method has to be either supergrouping, double cross, or slip and slide. So that's why we are going to end up doing this twice. I'm going to do it with slip and slide first, and then I'll do it again with supergrouping. Okay, so first step in slip and slide is the slip. So that means we're going to take our first term, our leading coefficient, slip it on down to the end and multiply. So that's 2 times 15. Now we're working in that alternate universe, that universe where our trinomial has changed. So I like to put quotations around it. It's now become x squared plus 11x plus 30. Where did the 30 come from? From multiplying the 2 by the 15. Now we play the P's and Q's game. What two numbers have a sum of 11 and a product of 30? So what times what is 30? Then when I add them together, I get 11. Those two numbers are 6 and 5. Okay, so now in my alternate universe, I'm going to factor that trinomial. X times x is how you get x squared, and then I bring in my p's and q's, positive 6 and positive 5. Now, this is not my final answer, because the second step of slip and slide is to slide. So I take my 2, slide it underneath both of these terms, and simplify the fractions if possible. Now, this will be my final answer, so I'm going to take it out of the quotations, bring it back to the real world. Can I simplify 6 divided by 2? Yes. 6 divided by 2 is 3, so my first binomial is x plus 3. Can I simplify 5 divided by 2? No. So we're going to put the 2 out in front. 2x plus 5 is my second binomial. And that's your final answer using slip and slide. Okay, now we're going to do the same quadratic, but some of you prefer supergrouping. So we're going to do it with supergrouping if I have enough space. So for supergrouping, it's kind of the same idea as slip and slide. You are playing the P's and Q's game, but you start off by multiplying the first and the last term together. 2 times 15 is 30. Now you play the P's and Q's game, exactly the same that you played up here. What two numbers have a sum of 11 and a product of 30? Well, look, we already did that right there. So we actually know that our two numbers are 6 and 5. We already did that work. So what do we do with that? Well, we break up the middle term into 6x and 5x, because 6x plus 5x is still 11x. Then you bring down the first term, and you bring down the last term. Now we factor by grouping, which we have done multiple times now. Put the first two in a group, put the second two in a group, find the GCF of both. For the sake of time, I'm going to do this step a little bit quicker than I normally would. So that I know that 2x is the GCF of 2x squared and 6x, so I'm going to factor out 2x. And that leaves me with 2x times x is 2x squared, and 2x times 3 is how I get 6x. The second one, I know 5 is the greatest common factor, so I factor out 5. 5 times x is how I get x, and 5 times 3 is how I get 15. The common binomial factor here is x plus 3, so that means my first binomial and my final answer is x plus 3. Second binomial is the GCFs, 2x plus 5. So you'll see how two different methods produced the same answer. All right, moving on to number 12. Same thing with number 12. There are two different ways to do this one. So we will go through it one way and then go through it another way, and then 14 and 16 are a lot quicker. All right, number 12, is there a GCF? So I know 10 doesn't go into 46 and 24, but something that stands out to me here is that all three numbers are pretty big. They're all double-digit numbers. 10 is a pretty big leading coefficient, which leads me to believe that there's most likely a greatest common factor here. What also stands out is that all three terms are even, which leads me to believe that 2 might be the greatest common factor. So I'm going to factor out 2, and that leaves me with a trinomial. So yes, there is a GCF here. When I take 2 out of 10, r squared, I'm left with 5r squared. When I take 2 out of 46r, I'm left with 23r. And when I take 2 out of 24, I'm left with 12. Okay, now, based on what we have left, how many terms are there? I see 3 terms inside of this expression, which means it's a trinomial. So when I go to my flowchart, it all depends on, is there a leading coefficient? Yes, 5 is the leading coefficient. Is 5 a perfect square? No. Is 12 a perfect square? No. So this is not a perfect square trinomial, which means similar to up here, my methods are essentially slip and slide and supergrouping, or double cross for those of you who like it. So I'm going to do again, I'm going to do slip and slide first, then I'll do the same one with supergrouping. So for slip and slide, first step is the slip. Take the 5, bring it on down to the 12. 5 times 12 is 60. So now we're working in that alternate universe. Now here's the thing though, our final answer is still going to have 2. So I'm going to bring that 2 along for the ride. That 2 is still part of my final answer, part of my product. My alternate universe is now r squared minus 23r plus 60. Where'd the 60 come from? It came from slipping the 5 down to the 12. Now we play the P's and Q's game. What two numbers have a sum of negative 23, product of 60? So what times what is 60? That when I add it together, I get negative 23. The things that stand out to me are negative 20 and negative 3. So now we're going to use that to factor our little alternate universe one. So again, that 2 is still a part of it. That 2 doesn't change. And inside we have our product of 2 binomials. R minus 20 and R minus 3. R times R is how we get R squared, and then the negative 20 and the negative 3 from there. Last step, the slide. Take the 5 that you originally slipped, slide it underneath, simplify both fractions. So now we're taking it out of our alternate universe, and this will be our final answer. 2 times a binomial times a binomial. 20 divided by 5 is 4, so my first binomial is r minus 4. Can't divide 3 by 5, so we slip it in front, 5r minus 3. And there's your final answer. Let's see if we get the same answer using supergrouping. We should. If we didn't, then we did something wrong. So for supergrouping, I'm going to go ahead and do the first step, just like we did in the first one. Factor out the 2, and then that's going to leave you with 5r squared minus 23r plus 12. And now we're going to supergroup. So for supergrouping, the first step, very similar to the first step here, you multiply the first and the last term together. 5 times 12 is 60. Then you play the P's and Q's game. What two numbers have a sum of negative 23 and a product of 60? Well, again, we already did that math over here with slip and slide. We know that those two numbers are negative 20 and negative 3. So that means we're going to break up the middle term into negative 20r and negative 3r. Bring down the other two terms, so bring down the positive 12, bring down the 5r and 5r squared, excuse me, and then what did I forget? Don't forget to bring down the 2. That 2 is part of your product. You want to bring it down the whole way. All right, for supergrouping now, we put them into our groups, 5r squared and 20r, negative 3 and 12. I'm going to do this step a little bit quicker. Factor out the greatest common factor. So the greatest common factor I know of 5r squared and 20r is 5r. So I'm going to bring down the 2 one more time, and then we'll have our final answer. So I factor out 5r from 20r and 5r squared. So when I factor out 5r, I'm left with an r minus 4. Because 5r times r is 5r squared, and 5r times 4 is 20. Over here, because this is a negative 3, and I know negative 3 goes into 12, I'm factoring out a negative 3. And I'm left with r, and then negative 3 times what is positive 12? Negative 4. Okay, final answer. 2 goes out in front, because that is your GCF, and it is part of the product. Common binomial factor here is r minus 4. Second binomial, 5r minus 3. Which, look at that, it's the exact same thing we got as doing it with slip and slide. Okay, so questions 10 and 12 are probably the most complicated ones on the entire worksheet practice. We're going to go ahead and end with questions 14 and 16, which are very quick because they are special cases. All right, number 14. Question 1, is there a GCF? Well, because 1 is one of the terms and only 1 can only be written as 1 times 1, no, there is no GCF here. There are 3 terms, and there is a leading coefficient, which means I can't use P's and Q's. So let's see. Is it a perfect square trinomial? Is 4 a perfect square? Is 1 a perfect square? Ah, yes they are. So let's test the middle term. So here we go. Take the square root of the first. Square root of 4n squared is 2n. Take the square root of the last term. Square root of 1 is 1. Now we're going to multiply these two and add them up to see if we get 4n. 2n times 1 is 2n. And 2n plus 2n is 4n. And that's the middle term. So we're going to factor this in 2 steps because it is a perfect square trinomial. Okay, so here we go. Simple as can be. Set up your 2 binomials. The first term is the square root of the first term, which was 2n. 2n and 2n. The second term is the square root of the last term, 1. Now, how do I know if it's plus or minus? Well, you look right here. Is the middle term positive or negative? The middle term is positive, so I know that these are both positives. And my final answer is 2n plus 1 squared. Why? Because it's the same exact binomial multiplied by itself. Now, you could have also done this using supergrouping or slip and slide, but it's a lot less work and takes a lot less time and a lot less space if you notice that it's a perfect square trinomial. All right, our last one, number 16. Is there a GCF? Again, because one of the terms is 1, that usually means no, there is no GCF. How many terms are there? There are 2 terms, which means we ask ourselves, is it a difference of 2 squares? Otherwise, it can't be factored if there was no GCF. So is it a difference? Yes. Are there 2 terms? Yes. Is 9 a perfect square? Yes. Is 1 a perfect square? Yes. So the method here is difference of 2 squares. Okay, so from here, I'm going to set up my answer. I know my answer is going to be a product of 2 binomials. And here we go. Just like perfect square trinomials, the first term is going to be the square root of the first term. So the square root of 9n squared is 3n. Second term in both my binomials is going to be the square root of the second term. Square root of 1 is 1. So here we go, final answer. First terms, 3n and 3n. Second terms, 1 and 1. Now notice there is no middle term. Up here with the perfect square trinomial, there was a middle term, which is why both of them are positive. If there's no middle term, that means we have to create 0. To do that, we make one of them positive and the other one negative. And there's the entire worksheet practice done. Please email if you have any questions or if I did something wrong, because you know I'm prone to doing that. Have fun factoring.